Some of you may have seen on our Slack group a while back, I asked the Monitorama community to describe your relationship between your ops and security team. And there was this nice bell curve, a lot of BFFs, which was great to see, mostly trending towards the positive, but definitely some room for improvement there. I also learned that some of you serve dual duty as both ops and security. Hats off to you. So we have even more reason to try to make these jobs more efficient. So at my company, DNA Nexus, we've had a lot of success gaining insight into complex systems using observability tools like Prometheus. So I wondered if we could create a similar culture of observability to help improve the relationship between security and ops. So takeaways from today's talk that I'd like everybody to get. Understanding the relationship between security and compliance. Learning some strategies for how to automate the compliance checking process. How to create some meaningful compliance SLOs and SLAs, so bridging some of those ops terms with security. And of course, how to become BFFs with your security team, or with yourself, if that's your thing. So what this talk is not, this is not a one-size-fits-all strategy. This is also not a comprehensive how-to for information security. I am not a security person myself. I just made some friends with some at my company, and I'd like to share a little bit of that story. So to start off, I'd like to share a little bit about my favorite webcomic, XKCD, which often inspires me in surprising ways. There's this one comic recently where one of the characters decided he wanted to write his own app so that he could make a wall display with a split screen on a tablet, with one side showing a webcam and the other side showing his calendar. So he starts teaching himself to code, but then he realizes quickly, hey, it would be way easier to just get two smaller phones on eBay and glue them together, literally. Now, this kind of thing sometimes gets a bad rep. We sometimes consider the process of gluing two separate solutions together as hacky, but I have another word for it. Glue ops. This is our mantra today. So my view is that as long as two separate tools have a clean, well-defined interface, that's actually way better to find an elegant way to glue them together rather than starting from scratch. Now, to get into a little bit about what we do at DNA Nexus, in recent years, we've seen a huge drop in the cost to sequence a human genome. This used to cost hundreds of millions of dollars in the time that most of us were alive here, which has made this technology more readily available to researchers as the price has dropped. There's a movement now called precision medicine, which is about taking advantage of the massive scale that we can sequence human genomes and process them with software to analyze large cohorts of DNA. And what used to require large sample sizes of human populations doing traditional kind of drug trials, we can now do with software and processing to look for cures for some nasty diseases. So in 2009, DNA Nexus was founded to bring this scalable cloud computing stuff that everybody else was enjoying to the precision medicine movement. And since DNA is considered personal health information, there's a lot of regulatory requirements around how we treat the security and privacy of DNA. So researchers collaborating on DNA across the world actually used to send each other boxes of hard drives through secure courier services to keep that data private and secure. So DNA Nexus, we take care of all that security and compliance and government regulation across the world with different regulations in different countries so that researchers can focus on the science. So we partner with a lot of amazing organizations. One of them is the St. Jude Children's Research Hospital, who has an amazing stat that in the 50 years they've been around, they've seen the childhood mortality rate for cancer drop and the survival rate increase from 20% to more than 80%. And to close that remaining 20%, they're looking heavily into genomics-based research to find cures and treatments for some cancers that have evaded treatment in the past. So we've partnered with them and Microsoft to help fuel some of that discovery. We also work with the FDA on some of their precision medicine initiatives. And as some of you, raise your hand if you work with the government at all. So as many of you know, compliance is hard with the government. They have some very strict regulations. One of them is called FedRAMP. And this is about one of the strictest security and compliance regulatory standards that we have to comply with. Now, when we talk about security and compliance, they're related, but they're not the same. So a good metaphor that I like to use is about pool safety. So compliance is all about learning from mistakes from the past and helping to prevent them in the future by following best practices and following lessons that we've learned from past mistakes. So the United States Consumer Product Safety Commission publishes this guideline for how to keep your pool safe. And this is about making sure that kids don't drown if they fall into the pool, right? So there's some regulations about how high the fence has to be, what the spacing between the bars should be. And this compliance is designed with safety in mind, but it's not the be-all, end-all, right? So they also, in this pamphlet, they say that barriers are not the sole method to keep your kids safe, and like, hey, parents, you still got to be parents, right? You still got to watch your kids. The door could be propped open to your gate. Kids could climb the fence. They could dig under it. Kids are sneaky, just like hackers trying to break into your system. You have to keep a watchful eye on them, right? So in an IT context, compliance doesn't mean that you're secure. Compliance just means at any one given moment, you've satisfied the requirements of whatever you're supposed to do, but you still need security people to be that watchful eye. So as an SRE, started to work on this shared vision with my security people, I came to know security wanted to spend less time measuring and enforcing compliance. I understand this is the standard dress code for InfoSec people, actually. So what does security want? They want more time hunting. My security lead likes to say, that I have to think like a hacker. I have to tip my hat with respect whenever I see a clever hack. But I want to spend more time hunting and less time measuring things, right? So what are some ways that we can make this process more automated? There's plenty of vendors that'll sell you a solution for that. There's some open source tools that exist as well. You can do a combination of the two. I'm going to focus here on some open source solutions, especially given that many of you don't even have a dedicated security team and you're kind of flying by the seat of your pants. So we use Prometheus internally at DNA Nexus. It's worked out great for us. Just a quick primer, Prometheus can observe and check up on just about anything that's measurable, anything that can expose some metrics. Usually we think of this in terms of Linux metrics like CPU, database stats about query timings and web server response times. But basically, at the end of the day, what Prometheus does is it just says, how you doing to some endpoint over HTTP. Let's say you have a breakfast robot that has an inventory of what it's got in its stores there, pancakes, waffles, and syrup. It can respond with anything, as long as it's a name of a metric and a value. So usually we think of it like telling us if a server is on fire. And it gives us some responses that tells us the case, and Prometheus can sound the alarm and page a human being. Prometheus can also work like this, though, with an intermediary process called an exporter. And what an exporter is great at doing is speaking the language of something else. So let's say we want to monitor AWS CloudWatch statistics. Prometheus doesn't know anything about CloudWatch. But Prometheus can ping a CloudWatch exporter process, which might even be running on the same server. And the CloudWatch exporter will then, in turn, speak the language of AWS, get a response back, and then it'll relay that back to Prometheus. Now, what does Prometheus do with all these metrics once it has them? It's like, I got all these metrics, what do I do? So what a lot of us like to do is use Grafana to make pretty graphs so that we can sit there and watch the paint dry and watch our disk space gradually filling up. We can also set up some clever alerts. Prometheus has some great support for predictive alerting. This is one of my favorite things, where you can send an alert if your disk is projected to fill up in the next 4 hours based on a linear projection, so that ideally you can have somebody deal with it while they're still awake. Okay, so now we know how to monitor stuff, but what if we want to use some of these tools to measure something different, like IT compliance in an automated way? So I started off by kind of looking at a lay of the land of what existing tools there were for compliance monitoring. And this tool popped up on my radar called Inspec. Has anybody heard of Inspec here? A lot of people, right? So it's been around for a while, a few years. It's made by Chef, but only really recently they actually broke off Inspec into its own separate GitHub org. And I think this was done, I'm not sure, maybe somebody from Chef can blink twice if I'm right, but to kind of signify that, that there was this desire to make it seem like it's not just for teams already using Chef, but could also be used as a standalone tool. That's how I took this to be meant, so hopefully that's right. Now, with InSpec, for the many years it's been around, you can use it to check security and compliance of individual VMs. What was new just in the last year or so is that they've added integrations for the 3 big cloud providers. So you can actually check security and compliance on your cloud solutions. You can check security groups. You can check user permissions. You can check all sorts of things that don't necessarily have to do with what's running on a server that you control. So InSpec is based off of Ruby and the RSpec test framework. So tests look like this. You write a control. A test is called a control. So this is a control that is checking the etc password file and making sure that it has the right permissions set and that it's not writable by the wrong people. You can also write a check like this, as I mentioned, with the cloud integration to check that a user has API access but not console access. So things like that. And there's a very rich language support for expressing all sorts of cloud-native things with InSpec. And some people say, well, like InSpec, isn't that just any other testing framework, right? But it's not just about the tech. It's like MySpace and Facebook and whatever, Snapchat, whatever the kids are using these days. It's about the community, right? So it's like wherever the users are, wherever the community is gravitating to, that creates the real value. So the InSpec community is really thriving, especially when it comes to security and compliance. So this is just a few handpicked things on GitHub. These are some benchmarks and baselines that are basically a bunch of those controls that I showed you earlier, security and compliance rules codified into executable tests that have been packaged up into these GitHub repositories that will tell you things like, is my Docker installation secure? Is my Kubernetes master secure? Is my Nginx server secure? And you can use these off the shelf. So something else that's really cool, I was kind of earlier, before I even discovered InSpec, I discovered something called the CIS benchmarks. So this is the Center for Internet Security. It's a nonprofit group that's comprised of Fortune 100 companies, leading security experts. And they publish these big PDFs with all kinds of guidelines for how to do things the right way. So there's a group on GitHub called the DevSec.org, and they've actually translated a whole bunch of these CIS guidelines from that kind of PDF, you sit by the fireplace and you read that, with a fine wine, into a usable InSpec profile that you can actually just use and run off the shelf. So to actually run them, it looks like this. You just run inspec exec, you pass the name of a GitHub repo, and you're off to the races. And it's going to tell you how many passed and how many failed. The better thing to do, because as we all know, we shouldn't run untrusted code off the internet, right? So the better thing to do is actually fork these repos into your own organization. And of course, then you can hand tweak them. You can add your own checks for things that were missing. You can remove things that weren't relevant to you. And then you can trust, as long as you've set up your GitHub permissions right, that nobody's going to put anything nefarious in there. When the checks run, they wind up looking like this. So you get a pretty familiar test output format. Green is good, red is bad. Shows you a nice little summary at the end. And this is great if you're just actually SSH'd into a host and you're running a spot check. You can also output to a different format, like the JSON format, if you want a downstream tool to consume this. There's a bunch of different reporters. You can pass the reporter flag and have a different format come out the other end. Here's what JSON looks like, pretty straightforward. Now, what if you want to actually run this not just on one server, but across your whole fleet of servers? So the InSpec docs recommend that you kind of use this command and control methodology to open up all of your servers to an SSH connection from an InSpec master server like this. And that way you can just have one place to centrally run all your tests and one place to keep track of all your results. Now, can you guess who this? Oh, I gave it away in the title. This look of disapproval is from my security team, right? They're like, you want all of our servers in our whole fleet to be opened up to SSH to run arbitrary commands from one central place, right? So Right, because if somebody compromised the inspect server, right, then they could install malware, they could, steal your data, they could basically have one way to access everything in your fleet. So that's bad. Now, Chef does provide a commercial solution to allow, instead of doing it this way, you can actually have inspect run and push results to a central Chef Automate server. And if you're already a Chef shop and you've already got Chef Automate, that might be a great possibility for you. I wanted to see if we could make this work using some existing free open source tools. So I went with this approach of running inspect locally on each machine and outputting the results to, again, using that portable JSON format. But now we got all these JSON files just sitting there on this server. So I was like, if only there was a way to pull all these results and aggregate them into one place. So does anybody know of a good pull monitoring tool? Prometheus. Right. So, but there's just one problem. Prometheus is like, JSON, what do I do with that? Prometheus doesn't speak JSON. Prometheus has its own metrics format, right? So what do we do when we have two things that don't work together? Glue ops. Yes, extra credit in the front. So I wrote a little exporter. Again, remember, an exporter in Prometheus terms is an intermediary process that can translate between two things that don't speak the same language and make them talk Prometheus metrics. So I wrote Prometheus exporter. It's a little lightweight process that runs on each machine. It consumes those JSON results, distills them down into Prometheus metrics, and makes them available for Prometheus to scrape. So it winds up looking like this. You've got your JSON format. It converts them to a very distilled down format here that just basically shows you how many passed, how many failed, and how many were skipped if they weren't applicable. The label that's added here called profile just shows you that outer grouping of the tests. So in this case, this was the DevSec Linux baseline. And then also, when Prometheus scrapes this, it'll also append the host as a label, or it calls it the instance as well, so you can see which instance produced which metrics. So if you're looking at like from the Prometheus server view, it'll look something like this. You've got one group of metrics for one server on one baseline, on one profile, and that was the top three are for my dashboard server that's running Prometheus itself. It's checking Docker security, and then I've got two web servers that are running the SSL baseline to make sure that Nginx is secure. So we wind up with three pieces of context. We learned about the importance of tracking context in our metrics here. So we've got instance, profile, and status to work with. Now we can graph them. Of course, we can make pretty dashboards to show that things are secure or not secure, but we don't want to rely on human eyeballs to make sure that we're compliant, right? So the better thing to do is create alerts. And when we think about a good way to define alerts, we've learned a lot in this conference about SLOs and SLAs. So a service level objective, or an SLO, defines that boundary for what we consider to be an acceptable level for a metric. And really, when it comes to compliance, I'm a big fan of the broken windows principle. It's like, anything other than 0 is not acceptable, right? So for our SLO, we have this set to 0, because if we start from the assumption that all compliance checks must always pass, then we never have to make a decision when we get paged about whether to ignore an alert or not. We can always treat it as something that needs to be dealt with. So to get started, I recommend running the inspect checks and only having your passing tests as what's part of the monitoring suite. Still keep track of what's failing, but file tickets to fix those, and then as they're fixed, add them to the monitoring suite so that they don't regress. Now, if we want to make the alerts themselves actionable, what do we do, right? So the CIS that I mentioned earlier that creates these great PDFs, in addition to just providing guidance, they provide a lot more. So when I was looking about how to secure our Docker installations, I learned some stuff like this, like, oh, content trust is disabled by default in Docker. You should enable it. Okay, well, why should I enable it, right? Why should I trust you, PDF document? So, but then, like right in the next section here, it's like, oh, rationale. So it talks about why this default is set the way it is and why we should change it. And at the end of the day, this ensures that these containers are coming from where we think they're coming from. So great. So I got the how and I got the why. So I was delighted to see that when the DevSec org ported the CIS Docker benchmark to InSpec, they actually brought all of that useful descriptive metadata with them and they encoded that into the inspect profiles. So they also annotated this with some helpful, a section called refs that actually provides some additional links where you can go off and learn more about some other articles from all over the web about how to understand what these checks are doing and why. But there's just one problem. All of that descriptive metadata just gets thrown out by all of the default inspec. Here's the HTML reporter that comes with inspec, and it just gives us this gobbledygook of errors, but it doesn't show us any of that useful descriptive stuff. It does show up in the JSON output, but JSON isn't very human readable for somebody who's getting paged and wants to know what to do, right? So we're back to this problem again. So what do we do when we have two things that don't work together? Glue ops. You're learning. So I used a tool called Marked, which uses the popular Markdown format. It can render things in HTML to convert this illegible JSON blob into a nice, easy-to-read format that looks something like this. So it hoists all the failures up at the top. They are hyperlinked, and they drill down into a report that shows you the details of the failure. And then also at the bottom, you can see the descriptive text that gives you the why and the how of why you should fix it and how you should fix it. I also realized that I could use the pieces of context that I showed earlier in those Prometheus labels, namely the profile name and the host name, to construct a unique URL at the point when we generate this alert so that we could point to the latest version of this inspect profiles report if we actually upload this report to like an S3 static site or something like that. So, so that way we can kind of bridge the gap. And when a person gets paged, instead of looking at this JSON blob, they can just click a link in the alert and see that report and know what to do. So, so SLOs are no good without SLAs, and SLAs can be financial, but for ops, SLA usually means like I agree to get woken up or paged or whatever. So context, our instance, our profile name, and at the bottom here you can see we're basically, I've got my S3 bucket name hard-coded in here, but we're just constructing a URL where we're assuming that my Prometheus exporter has uploaded this report into a well-known URL that's going to match these labels here, and then when somebody gets the page or the email or the Slack notification, they'll know where to go. So putting it all together looks like this. We got inspec running as a cron job on these machines, outputting JSON. We got our inspec reporter watching that JSON file, and two things are happening. Prometheus is scraping the inspec reporter, just getting our distilled down stats about how many passes and failures. We're also generating a friendly HTML report that the inspec exporter is uploading to S3. And that way, if we breach our SLO and our SLA gets triggered, firing an alert, our human operator there is going to just click on the link in the alert, get their helpful HTML report that's going to tell them the why and the how of how to fix it, and no stress. They got this, right? So we're going to show a little demo of this working in action here. We're going to pretend we've got a little org called GlueOps, which deals with the federal government. So they are FedRAMP compliant, which means that they have to use TLS 1.2 exclusively on their web servers. So here we go. So we got, oh wait, I forgot one piece of information. I have to introduce the characters in this short play here. Where did they go? Oh man. Oh, there we go. Okay, desktop to. If this is my worst demo glitch, I'm going to consider myself lucky. All right, this is very important. So we got Ian. He's been at the company for 5 years, and he likes hand editing server config files, right? Because YOLO, right? And then we got Lex. She's pretty new. She's been at the company 6 months, but she's really into Prometheus and actionable alerts, and she was at this conference, and she did everything that we just talked about, right? So, all right, back to the demo. So Ian's checking out for Friday. He's super excited for the weekend, and he's just going to make one quick config change just to like try to fix a bug that's been haunting him for a while. But he's totally going to roll it back before the weekend. So he's dropping into a shell. He's editing Nginx config. He's enabling TLS 1.1 because, like, why not? That's a compliance violation, but he's only going to do it for like 1 minute, so it's totally cool. And then like, oh, he kind of forgot to roll that back, but he's leaving for the weekend. He didn't tell anybody even what he did, right? So Lex is starting her shift, and she's like, cool, all right, see you, Ian, have a great weekend. Starting my on-call, nothing's going to go wrong. And bam, right off the bat, she gets this alert here, and she's like, Ian, you still there? Like, you're leaving me hanging, buddy. What's going on? But Lex is cool as a cucumber, and she's not going to panic because she's got all of the context she needs right here in this alert manager alert here. So as we looked at before, she's got the inspect profile name. So right off the bat, she knows she's got an SSL compliance violation. She knows which server it's happening on. And most importantly, she's got a link that she's going to click on right here that's going to take her right to that detailed inspect report to show her the why and the how of what to do. So she's clicking on that. It's telling her TLS 1.1 is enabled. It's telling her she needs to edit nginx conf and disable TLS 1.1 and then restart nginx. So she's like, no problem. Dropping into my shell here, undoing what Ian just did, restarting nginx, and she's just going to go back here, and she got the resolved message, and she's like, she's not going to rub it in, but she's just like, hey, heads up, I saved our butts, so you're welcome. So this is Lex. She keeps it cool, does compliance as code, and she has actionable alerts. Be like Lex, everybody. So just to recap, have that sit down with your security team. Whether you use this solution or something else, when you reach out as ops or SRE to security, they'll really appreciate it, and they'll be your BFFs in no time. So ideally, work on some kind of automated vision together. Consider using Prometheus to do this, because it's actually pretty easy and pretty cool, and you can take advantage of all this existing community tooling for it. Do that so you can encourage your security people to be hunters and not just tape measuring. Maybe they can keep the tank top, but lose the tape measure. And when you find two things that don't fit together, don't be afraid to use GlueOps. So thank you. If you're interested in participating in this project, check out this bit.ly link here, bit.ly/GlueOps. That'll take you to the GitHub repo where you can see everything in action here. You can also sign up for a Google group mailing list if you'd like to contribute to the discussion. You can also find me, if you're here at the conference, you can find me on our this Slack channel here to chat more. So thanks so much.